Guys, everything you need to know about neural networks A to Z. Let's do this.
So in this video, I want to be talking about one versus all strategy in neural networks. So let's draw these in a good diagram and actually explain them one by one. So in one versus all strategy, let's consider that we have several different examples. So I'm drawing several different nodes. Okay, that'll be enough. And then let's add a few hidden nodes. Let's add 5. Good. Now we can add the logits or the labels. Okay, great. Then we can say yes and no. We can have x1, x2, x3, x4, and x5. We can have yes or no. And we can have this the same thing over and over again. This is one versus all or sigmoid. So in this strategy, how they actually connect is, so each one goes to separate different cases. You can have I think you understand how each one actually connects. I know it's going to get quite confusing. Trying to just change the colors to make sure that it doesn't get that confusing at all. Yeah, it is quite complicated. So in this case, the same thing happens. We one by one map out all of the different natures. And this one would be fine. You can see that we map these all out. So in this neural network that we have here, how is it going to be divided? So we connect the input, the hidden layer. We have another hidden layer here. And this is the logits. So you can see how we're actually connecting these. So they actually answer our values. Suppose if we're trying to classify whether this object is a different animal, is this a dog? Is this a cat? Is this a tiger? Is it a lion? Is it a bear? So yes or no, yes or no, yes or no. All the options here. So we're going to be getting these answers depending on what we get. So that's basically one to all. This is one input. We can arrange this like that, for example. So guys, in this video, I'm going to be explaining the softmax. We talked about this. So let's go and continue with the softmax. So in softmax, this is quite interesting. So softmax, guys. So in softmax, let's consider this. So we can see here, we have different probabilities. They can be about somewhere ranging from 0 to 1, where this is like 80%, this is about 60%, 50 for example, this can be 90, this can be 30 for example. So in softmax, what we do is we're going to have to calculate the probability from 0 to 1. And this is something which is exclusive of the other function. They can be about 0.01, 0.02 for example, 0.68. Then we have, let me see, I just want to make sure we get all the values here. 0.09 and 0.20. So if we add all these up, you would get 1.00. So you want to make sure that all of these values here, these 5 values, are added up and we get a total of 1. So that's the softmax. So that's basic softmax. Now let's say full softmax. What's a full softmax? So this full softmax is, this example, this is a full softmax. Suppose we do this only, we calculate each probability for only about 3 values, the first 3, for dog, cat, and tiger. Suppose we say this is 0.5, 0.45, and 0.5. This is 1 already. So we're neglecting lion and bear. So this would not be a full softmax. But since we're calculating all the parameters which are available, this is a full softmax. Next we have candidate sampling. This is quite interesting. Check this out. So candidate sampling. So in candidate sampling, we can say that an input is somewhat similar to a dog and high chances of being a dog. Then let's say, for example, instead of dog, we have a beagle here, and we have a Doberman, and we have a Labrador, etc. So, and this is the same. This is lion, and this is a tiger. So what it means is the candidate sampling doesn't consider the values of lion, tiger. It only goes into the domain of beagle, Doberman, and Labrador, since we know that it is a dog. So that's how it actually samples up the values. So that is it, guys. And we do have one more thing. we have one label versus many labels. So softmax assumes that each example is a member of exactly one class. Some examples, however, can simultaneously be a member of multiple classes. Like for example, we can say you may not use softmax, or you must rely on only multiple logistic regressions. For example, if we say that we have exactly one item, a piece of fruit, for example, softmax can determine the likelihood that one item is being a pear, an orange, an apple, etc. So if your examples are images containing all sorts of things like a barrel of different fruit, then we have to use logistic regression exactly, because since softmax can only identify one different value at one time. If we're having multiple values and multiple groups of items, we have to use logistic regression and multiple logistic regressions. We have to divide these values one by one. So that's the basic, all the things you have to know about neural networks and softmax.
Hey guys, I hope you learned something out of this video. If you like the videos and if you want to watch more, want to learn about a specific topic, leave it in the comments below. If not, just give it a likes up and subscribe.